Yes, good evening everyone. So today we will study the first unit, that is economics of power generation introduction and the economics of power generation, that is economics of power plant, tariff and economic aspects in power generation. So introduction, the function of a power station is to deliver power to a larger number of consumers. However, the power demands of different consumers vary in accordance with their activities. The result of this variation in demand is that load on a power station is never constant, rather it varies time to time. The power demanded by the consumers is supplied to the by the power station through the transmission and distribution networks. As the consumer's load demand changes, the power supply by the power station changes accordingly. So base load and peak loads. So base load, what is mean by base load? Base load is the minimum level of electricity demand required over a period of 24 hours. It is needed to provide power to components that keep running at all times, also referred as continuous load. So peak load is the time of high demand. These peaking demands are often for only shorter durations. In mathematical terms, peak demand could be understood as the difference between the base demand and the highest demand. The examples of household loads, microwave oven, toaster, and television are examples of peak demand, whereas refrigerator and HVAC systems are examples of base demand. This constant power, which is required at all times, is called the base loading. But during a special event like the final match of World Cup, the demand will be more, as a lot of people will watch TV. This short is high demand period is considered to be a peak loading. Variable load on power station. The load on a power station varies from time to time due to uncertain demands of the consumers and is known as variable load on the station. The consumers require their small and large block of power in accordance with the demands of their activities. Thus, the load demand of one consumer at any time may be different from that of the other consumer. The result is that load on the power station varies from time to time. Effects of variable load. The variable load on a power station introduces many perplexities in its operation. Some of the important effects of variable load on a power station are need of additional equipment and increase in production cost. Load curves. The load varies during the whole day, that is 24 hours, are recorded half hourly or hourly and are plotted against time on the graph. The curve thus obtained is known as daily load curve, as it shows the variations of load with respect to time during the day. The monthly load curve can be obtained from the daily load curves of that month. For this purpose, average values of power over month at different times of the day are calculated and then plotted on the graph. So load curves are different types are residential load curve, industrial load curve, commercial load curve. So importance of load curves. The daily load curve shows the variations of load curve on power station during different hours of the day. The area under the daily load curve gives the number of units generated in the day. Units generated per day is equal to area in kilowatt hour under daily load curve. The highest point on the daily load curve represents the maximum demand on the station on that day. Importance of load curves. The ratio of the area under the load curve to the total area of the rectangle in which it is contained gives the load factor. So load factor is equal to average load divided by maximum demand. Average load in 24 divided by maximum divided in 24. So area m kilowatt hour under daily load curve divided by total area of rectangle in which the load curve is contained. The load curve helps in selecting the size and number of generating units. The load curve helps in preparing the operation schedule of the station. Important terms and factors. Connected load. Connected load is the sum of continuous ratings of the load consuming apparatus connected to the system. Cold reserve is that reserve generating capacity which is available for the service but not in the operations. Hot reserve is that reserve generating capacity which is operation but not in service. Spinning reserve is that generating capacity which is connected to the bus and ready to take load. Firm power is the power intended to be always available even under emergency conditions. Connected load is the sum of continuous ratings of the load consuming apparatus connected to the system. A power station supplies load to thousands of consumers. Each consumer has certain equipment installed in his premises. If a consumer has connections of 500 watt lamps and power point of 500 watts, then connected load of the consumer is 5 into 100 plus 500 is equal to 1000 watts. The sum of the connected loads of all the consumers is the connected load to the power station. Important terms and factors in that we will go to the next point, that is maximum demand. It is the greatest demand of load on the power station during given period. In the load curve example, the maximum demand of the power station during the day is 6 megawatt and it occurs at 6 pm. Maximum demand is generally less than the connected load because all the consumers do not switch on their connected load to the system at a time. The knowledge of maximum demand is very important as it helps in determining the installed capacity of the station. The station must be capable of meeting the maximum demand. Demand factor. It is the ratio of maximum demand on the power station to its connected load. Demand factor. Demand factor is equal to maximum demand divided by connected load. The value of demand factor is usually less than 1. It is expected because maximum demand on the power station is generally less than the connected load. If the maximum demand on the power station is 80 megawatt and the connected load is 100 megawatt, then the demand factor is 80 divided by 100, that is equal to 0.8. The knowledge of demand factor is vital in determining the capacity of the power equipment. Average load. The average of loads occurring on the power station in a given period, day or month of year is known as average load or average demand. Daily average load. Number of units in terms of kilowatt hour generated in a day divided by 24 hours. Monthly average load. Number of units in terms of kilowatt hour generated in a month divided by number of hours in a month. Yearly average load is equal to number of units in terms of kilowatt hour generated in a year divided by 8760 hours. Load factor, the ratio of average load to the maximum demand during a given period is known as load factor. Load factor is equal to average load divided by maximum demand. If the plant is in operation for T hours, load factor is equal to average load T divided by mass demand T. So units generated in T hours divided by maximum demand into T hours. The load factor may be daily load factor, monthly load factor, or annual load factor if the time period considered is a day or month or year. Load factor is always less than 1 because average load is smaller than the maximum demand. The load factor plays key role in determining the overall cost per unit. The load factor may be daily load factor, monthly load factor, or annual load factor if the time period considered is a day or a month or year. Load factor is always less than 1 because average load is smaller than the maximum demand. The load factor plays key role in determining the overall cost per unit generated. Higher the load factor of the power station, lesser will be the cost per unit generated. Diversity factor, the ratio of the sum of individual maximum demands to the maximum demand on the power station is known as diversity factor. Diversity factor is equal to sum of individual maximum demands divided by maximum demand on power station. A power station supplies load to various types of consumers whose maximum demands generally do not occur at the same time. Therefore, the maximum demand on the power station is always less than the sum of individual maximum demands of the consumers. Obviously, diversity factor will always be greater than 1. The greater the diversity factor, the lesser is the cost of generation of power. Plant capacity factor. It is the ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. Thus, the considered period is 1 year. Annual plant capacity factor is equal to annual kilowatt hour output divided by plant capacity into 8760. Plant use factor, it is the ratio of kilowatt hour generated to the product of plant capacity and the number of hours for which the plant was operation. That is, plant use factor is equal to station output in kilowatt hour divided by plant capacity into hours of use. Suppose a plant is having installed capacity of 20 megawatt and produces annual output of 7.3526 kilowatt hour and remains in operation for 2190 hours in a year, then plant factor is equal to 7.35 into 10 raised to 6 divided by 20 into 10 raised to 3 into 2190 is equal to 0.167, that is 16.7%. Load duration curve. So this is the load duration curve. Electrical tariff. The electrical energy produced by a power station is delivered to a large number of consumers. The consumers can be persuaded to use electric energy if it is sold at reasonable rates. The supply company has to ensure that the tariff is such that it not only recovers the total cost of producing electrical energy but also earns profit on the capital investment. The rate at which electrical energy is supplied to a consumer is known as tariff. Although tariff should be include the total cost of producing and supplying electrical energy plus the profit. Consideration has to be given to different types of consumers, example industrial, domestic and commercial, while fixing the tariff. Objectives of tariff. Like other commodities, electrical energy is also sold at such a rate so that it not only returns the cost but also earns reasonable profit. Therefore, a tariff should include the following terms: recovery of cost producing electrical energy at the power station, recovery of cost on the capital investment in the transmission and distribution systems, recovery of cost, operation and maintenance of supply of electrical energy, that is metering equipment, billing, etc. A suitable profit on the capital investment. So simple tariff. So when there is a fixed rate per unit of energy consumed, it is called a simple tariff or uniform rate tariff. So disadvantages of this are: there is no discrimination between different types of consumers, since every consumer has to pay equitably for the fixed charges. The cost per unit delivered is high. It does not encourage the use of electricity. Flat rate tariff. When different types of consumers are charged at different uniform per unit rates, it is called a flat rate tariff. Block rate tariff. So when a given block energy is charged as specified rate and the succeeding blocks of energy are charged at progressively reduced rates, it is called a block rate tariff. Two-part tariff. When the rate of electrical energy is changed on the basis of maximum demand of the consumer and the units consumed, it is called a two-part tariff. Power factor tariff. The tariff in which power factor of the consumer's load is taken into consideration is known as power factor tariff. So there are some different types of tariffs: sliding scale tariff, KW or KVA tariff,